Hello everyone. In this lesson, we are going to learn about the continuity of a function on an interval. So here, we will be illustrating the continuity of a function on an interval and solve problems involving continuity of a function. Now, to start, let us recall that we can only say that a certain function is continuous when there is no holes, no gaps, no breaks at that certain point on the graph of the function. Now, what if we are going to consider an interval? Okay, so to illustrate that one, let's consider the graph of the function below and determine whether the function is continuous on the intervals. So we have three open intervals here, -1 to 1, -infinity to 0, and 0 to positive infinity. And suppose ito yung graph natin. Okay, now, on the open interval -1 to 1, okay, para masabi nating continuous yung ating function, on this interval, dapat wala tayong madadaan ng holes, gaps, or breaks on the graph of the function corresponding to the given interval. So -1 is here, and +1 is here. Now, tracing the graph, we cannot see any holes or gaps or breaks. So in that case, we can say that the function is continuous on the interval -1 to 1. Okay? Now, how about on the interval -infinity to 0? So therefore, there is no bound sa left side ng interval. Kaya -infinity siya. Now, in this case, 0 is here. Okay, so the value of the function at x equal to 0 is here. Now, tracing the graph going to -infinity, you cannot see any holes, gaps, or breaks here. So in that case, we can say that the function is also continuous on the interval -infinity to 0. Now, how about from 0 to positive infinity? So we have this interval, 0 to positive infinity. So from this point here, going to positive infinity, wala tayong madadaan ng holes, gaps, nor breaks. So from that, we can say that the function is continuous. Okay, so on the given intervals here, the function is continuous. Okay, now how about if we are going to change the function? So, iba na yung function na i-consider natin. And the intervals are the open interval -1 to 1 and the closed interval 0.5 to 2. Now, from -1 to 1, so on the interval -1 to 1, so -1, so we have this point here on the graph, and +1, so here. So as you can see, if you are going to trace the graph, makakadaan tayo ng isang hole dito. So therefore, from that, there is already a discontinuity. And automatic, we can say that the function is discontinuous on the open interval -1 to 1. Okay? Because meron tayong nakitang isang point na makakapa-discontinuous sa ating interval. Okay? Now, how about from 0.5? 0.5 is it is somewhere here to +2. So +2 is somewhere here. So makikita natin na walang holes, walang gaps, nor breaks sa ating graph. So in that case, we can say that on the closed interval 0.5 to +2, the function is continuous. So as you can see here, it is easy for us to determine whether a function is continuous or not on the given interval if given yung graph ng function. Now, how about if hindi siya given? So in that case, we will need the following concepts. Okay, so first, let's have this definition for the one-sided continuity. A function f is said to be continuous from the left at x equal to c if f of c is equal to the limit of f of x as x approaches c from the left. So if that happens, the function is continuous from the left at x equal to c. So dapat yung value ng function ay the same sa left hand limit ng function. Okay? And a function f is said to be continuous from the right at x equal to c if f of c is equal to the limit of f of x as x approaches c from the right. So dito naman, yung value ng function ay the same dapat sa right-hand limit. That's why ang tawag dito ay mga one-sided continuities. So we have continuous from the left and continuous from the right. Okay? Now, we have the following theorems that will help us determine whether a function is continuous or not on a given interval. First, we have all polynomial functions are continuous everywhere. So therefore, a polynomial function is continuous everywhere. So in that case, yung polynomial function natin ay continuous sa lahat ng real numbers. Kahit anong numbers pa yan, continuous siya. So it is continuous on the set of real numbers. Okay, so wala kang makikitang discontinuity sa polynomial function. Okay, next. The absolute value function f of x equal to the absolute value of x is also continuous everywhere. So the set of real numbers again. Kasi if you are going to imagine the graph of an absolute value function, pa-V yan, and wala kang makikitang holes, gaps, or breaks kahit saan. So in that case, it is continuous everywhere on the set of real numbers. Okay? We also have here the rational functions are continuous on their respective domains. So in that case, you need to identify those restrictions that will make the function undefined. And in that case, at that point na makakapa-undefined sa ating function, discontinuous yung ating rational function. Okay, so in this case, hahanapin nyo lang yung makakapag-undefined sa ating function. Okay, so there is already restrictions here. And for the last one here, the square root function f of x equal to the square root of x is continuous on its domain. And the domain of this function is from 0, so 0 is included, to positive infinity. Okay, so you need to get its domain lang. Okay. Now, another theorem that you will need to easily determine whether a function is continuous or not on an interval, we will have this one. A function is said to be continuous everywhere if f is continuous at every real number. So, kada kuha mo ng real number, dapat continuous yung ating function. If that's the case, it is continuous everywhere, like our polynomial function. So in this case, we also say that f is continuous on the set of real numbers. Okay, next. The function is continuous on the open interval a, b if f is continuous at every point x in a, b. So in that case, dapat machi-check mo lahat ng point inside the open interval AB. So if this is your A and B, open siya. Okay? So lahat ng points na makikita natin dito, dapat yung function ay continuous. If merong isa na makakapag-discontinuous sa kanya, automatic, the function is not continuous or discontinuous on that given open interval. Okay? Now, for the third one, so we have on the interval close at A and open at B. If F is continuous on AB, so balik tayo sa second property dito, and from the right at A. So therefore, you need to check the open interval AB. So dapat lahat ng points inside that open interval, continuous yung function natin. At from the right at A. So balik tayo sa one-sided continuity. So dapat si f of A is equal to the limit of f of x as x approaches A from the right. Okay, so you need to check two conditions here. Now, for number 4, si B naman yung closed dito. So, it is continuous if F is continuous on AB again. So, balik tayo kay number 2. And from the left at B. So, therefore, F of B should be equal to the limit of F of X as X approaches B from the left. Okay, so kukunin nyo yung left-hand limit in this case. For number 5, it is continuous on the closed interval AB if F is continuous on this half closed, half open AB and this one. Okay, so balik kayo kay 3 at kay 4. So dapat masatisfy yung 3 at saka si 4. Okay, number 6. So on A to positive infinity, so this is continuous if f is continuous at all x greater than a. So if this is your a, so dapat greater than a. Lahat ng points na makikita natin dito, dapat continuous yung ating function. Okay, so actually almost the same lang siya sa number 2. Si number 2 is more specific kasi meron siyang endpoint sa right side. Dito, walang endpoint. Okay? Number 7, so on the close at A to positive infinity, if F is continuous on A to positive infinity, so balik kayo kay number 6, and from the right at A. So, kukunin nyo ulit ito. Okay? So, yon. The number 8, on negative infinity to B, if f is continuous at all x less than b. So if this is b here, so going to the left, dapat continuous sa lahat ng points there. Okay? And for number 9, for the last one, negative infinity to b, close at b, if f is continuous on negative infinity to b, so we have number 8, so balik kayo kay 8, and from the left at b, so balik kayo dito sa one-sided continuity. So therefore, ito lang titingnan nyo. If merong closed, like this one, yan, okay, gagamitin natin yung one-sided continuity. Okay? So para mas ma-understand natin ito, let's consider the following illustration. First, we have, is the function f of x equal to, so this is a piecewise function. So the sub-functions are x minus 1 when x is less than 4 and square root of x plus 1 when x is greater than or equal to 4, continuous on the interval negative infinity to 4 and 4 to positive infinity. 4 is included. Okay? So let's try negative infinity to 4. Okay? So here, when our interval is negative infinity to 4, those are values less than 4. So our f of x will be equal to x minus 1. The subfunction that we are going to use is x minus 1 since x here is less than 4, right? And take note, this function is polynomial, right? X minus 1 is a polynomial function. Thus, according to our theorem, all polynomial functions are continuous everywhere. So it will follow that this function is continuous on negative infinity to 4. Thus, f is continuous on negative infinity to 4. So it is important to mention the interval. Okay? Next, letter B. We have close at 4 to positive infinity. So we are going to use the second subfunction because from 4 to positive infinity, we will use those are values greater than or equal to 4. So we will use this one. Okay? So in this case, f of x is equal to the square root of x plus 1. So this is now a radical function. And take note, square root of x from our previous theorem is continuous on 0 to positive infinity, right? And since 4 to positive infinity is inside this interval, okay, since 4 to positive infinity is inside this interval, we can say that this function is continuous on the interval 4 to positive infinity. Okay, so yon, it will follow. So that's it for the first illustration. Now for the second one, we have the function g of x. So we have three subfunctions here. 1 over x plus 1 when x is less than 0. X squared minus x plus 1 when x is between 0 to 2 inclusive. And 5 when x is greater than 2. So is it continuous on the given intervals negative infinity to 0? The close interval 0 to 2 and 2 to positive infinity. So first letter A, we have on negative infinity to 0, g of x is equal to, so what will be our subfunction? So in this case, negative infinity to 0 are those values less than 0. So therefore, we will use the first subfunction. So g of x now is equal to 1 over x plus 1. This is a rational function. And according to our theorem, rational functions are continuous on its domain. So we need to check the restriction. So in this case, g of x is undefined only when x plus 1 is equal to 0. Okay? So it is undefined when x plus 1 is equal to 0. And this will follow that x is equal to negative 1. Right? And since negative 1 is an element of negative infinity to 0, negative 1 is inside this interval. And according to the theorem, we can only say that the function is continuous on this interval negative infinity to b if it is continuous at all values x less than b. So in this case, since we have found one value that will make the function undefined, therefore, we can say that g is discontinuous on negative infinity to 0. Okay, because we have found one value inside the interval that will make the function undefined. So automatic for letter A, discontinuous siya on the given interval, negative infinity to 0. Okay? Now let's have letter B. We have from 0 to 2 inclusive. So on this interval, our function will be x squared minus x plus 1. And in this case, this is a polynomial function. And all polynomial functions are continuous everywhere. Thus, g is continuous on 0 to 2. Okay? So, madali lang siya. And for letter C, we have on 2 to positive infinity. The function that we are going to use is the third subfunction, right? So g of x is equal to 5, which is a constant function, and it is still a polynomial function. So therefore, we can say that g is continuous kasi polynomial ulit siya on 2 to positive infinity. Okay, so ganun lang siya. So madali lang siyang malalaman. You need to familiarize the theorems that we have discussed. Okay? Now, how about this one? Determine the largest interval over which f of x equal to x over x squared minus 1 is continuous. Okay? Now, look at the function. Take note that this function is a rational function, right? And take note from our previous theorem, all rational functions are continuous on their respective domain. So in this case, para ma-solve natin ito, ang atake dito ay to solve first the domain of the function. Okay, so we have here the solution. Observe that f of x equal to x over x squared minus 1 is not defined when the denominator is equal to 0, and that is when x squared minus 1 is equal to 0. Okay? And take note that x squared minus 1 equal to 0 means that when we solve for x, we will have x squared equal to 1, right? Now, taking the square root of both sides, we will have x equal to plus minus 1. That's why we have here that is x is equal to plus minus 1. Therefore, plus minus 1 is not included in the domain of the function. So therefore, we have here hence the domain of f is the set of real numbers except the set containing negative 1 and 1. Okay? Now, from the previous theorem, a rational function is continuous on its domain. Okay? Therefore, we can say that f is continuous over the interval, the set of real numbers, except the set containing negative 1 and 1. So this will be the largest interval, which is the domain of the function. Okay? So that answers our problem here. Now, for our last example, let us consider this problem. Determine the largest interval over which the function f of x equal to square root of x plus 2 is continuous. Now, in this case, our first candidate to be the largest interval is the domain of the function. So, therefore, we need to identify the domain of the function square root of x plus 2. So, for our solution, we have observed that f of x equal to square root of x plus 2 is defined only if yung nasa loob ng radical sign is greater than or equal to 0, right? And ibig sabihin yan, si x is greater than or equal to negative 2. So this will be our candidate. Si x greater than or equal to negative 2. Ibig sabihin, that is from -2 inclusive to positive infinity. So that is the domain of our function. Okay? So take note that if we have the interval a to positive infinity, we can only say that this one is continuous if continuous siya from a to positive infinity and from the right of a, right? So we need to check the two conditions. So first, let us check for those values from a to positive infinity. Our a is -2. Okay? And we can only say that the function is continuous at this interval or a to positive infinity if sa lahat ng points inside this interval, the function is continuous. So in this case, kukuha tayo ng points inside the interval at dapat lahat ng points yon. So that's why we have here for all c. So this is a point inside our interval. F of c is equal to the square root of c plus 2. Bakit kinuha natin si f of c? Because para malaman natin na continuous siya sa lahat ng points, dapat si f of c is equal to the limit of f of x as x approaches c. This is according to the continuity of a function at a point. Right? So in that case, we need to check this one. So we have solved here f of c, and that is equal to, so we will just substitute c to our function. So si x magiging c, so we have square root of c plus 2. Okay, so we have this one. And the limit of f of x as x approaches c, f of x is square root of x plus 2, so we have it here. So we will just do direct substitution, so that will become square root of c plus 2. Is this greater than 0 yung nasa loob? The answer is yes, because our interval hindi kasama si -2. Right? Ito magiging 0 lang if c is -2. Pero hindi kasama si -2 dito. Open interval siya. So this will always be greater than 0. So it exists. And they are equal. So this one is satisfied. So we can say that f is continuous over the open interval -2 to positive infinity. So this is our first conclusion. Next, we need to check the continuity from the right of a. So our a again is -2. And we can only say that it is continuous from the right at a if f of c is equal to the limit of f of x as x approaches c from the right. Okay, so in this case, we will have when x is equal to -2, si f of c yung sinusolve natin. So c is -2. So f of -2 is equal to the square root of -2 plus 2. And that is equal to 0. We are solving for the value of the function. So that is 0. Next, the limit of the square root of x plus 2 as x approaches -2 from the right, using table of values, the answer will be 0. So in that case, f of c and the limit of f of x as x approaches c are the same. So therefore, we say that f is continuous from the right at x equal to -2. So in this case, na-check natin tong first condition at yung second condition. So it will follow that yung function ay continuous on this interval, which is this one. Therefore, for all x element of the interval -2, -2 is included from to positive infinity, f of x is equal to square root of x plus 2 is continuous. So this will be the largest interval. Okay? So that ends the lesson on continuity of a function on an interval. I hope you have learned something, Thank you for watching.